Hope you're having a great day and welcome to the query intent classification hands-on tutorial session. In this session, we're gonna go through a language understanding task that is very important in the modern search systems, which is the query intent classification task. So we will go through how to build a production-ready CNN model for query intent classification using the DTeX framework. DTeX framework is open sourced by LinkedIn, and it is a deep neural text understanding framework. And for more details, please refer to our GitHub page. So let's first take a very brief view of query intent understanding in search systems. This is actually the process for understanding the user's intents behind the search query. For example, is a user trying to search to buy certain products? Are they trying to look for certain types of jobs? Or are they trying to book some restaurant, etc.? So these are all different intents that's available provided by the search platform. And understanding the intents associated with the queries very accurately allows the search engine to trigger the corresponding vertical searches, as well as it could also benefit other downstream tasks such as document ranking. So this is the task that we're going to look at for today's for this hands-on tutorial. And this tutorial setup can be found on the left panel. Basically, we're first going to set up the environment, and then we're going to download and pre-process the data set. And followed by that, we will prepare the data to in the format of DTeX training data so that it can be accepted by DTeX training framework. And then we will train a CNN model for this intent classification. And we're gonna see the trained model put into action, like how we can do inference with it. And the data set that we're using today is publicly available. You can find it on GitHub. It is called the Natural Language Understanding Benchmark Dataset. Basically, it is labeled data that contains 7 different types of intents. That's very common in modern search engines, including the following. So they have search creative work, get weather, book restaurants, play music, add to playlist, rate books, as well as search screening events. So out of the 7, we will not be using play music because there is some data downloading issues with it, but it doesn't really affect our purpose of the tutorial. So again, we're going to use 6 of the classes that's listed here. Okay, so let's just jump into the tutorial. So first, let's just run the setup, the environment setup step. So in this step, we're actually installing DTeX, and this is pretty much all we need to do for setting up the environment. And let's just wait for it to finish. Okay, so even though we see there are some errors here and some warnings, it doesn't really affect running the notebook. So let's just proceed. And the next step, we're gonna download and pre-process the dataset. So again, we can download the dataset that's publicly available from the GitHub page. So this command will download the dataset, and then let's do some pre-processing. So the dataset is actually quite clean, and we're just going to do some very simple pre-processing, such as lowercasing, white space normalization, and things like that. Next, we're defining all of the constants that we're going to use for this notebook. So first of all, we have the class labels, and there are 6 of them. And next are the feature names that's acceptable for dtext. So you can go to the link to look at the naming format required by dtext. So that's our constants. And the next cell, we're just parsing the dataset to load the train and test data. And I've also outputted the count for all of the different labels that we have. And next up, we're gonna do some simple pre-processing for the text data, like stripping, lowercasing, as well as adding spaces before and after punctuation, things like that. And if you're interested, you can actually make a copy of the notebook and then just try to also add some other steps if you're interested. So let's just run this, and we've printed some samples from the train set, as well as from the labels, the corresponding labels, and you can see the pre-processed text data. All right, so let's move on, and followed by that, we will prepare the train set into, we will split the train set into train and dev set. So this is a standard train test split. So after that, we've got our train set, dev set, and our test set. And you can see the dataset counts printed out here. So after the pre-processing, we're gonna prepare the dtext dataset. And dtext actually accept TF records. That's very standard. And we're just going to prepare all of the text data as well as some dense features into the TF records so that it can be read by the dtext training framework. And again, if you're interested, please check out the training manual for dtext, as there are a lot more other functions that we provide. It's not just limited to what we just show in the tutorial. Okay, so I just run this this cell. Basically, what it did is that for each of the query and label pair, is gonna create the TF record features. And I've also added a just one single white, what we call white feature. It's actually just dense feature, that is the count of the tokens in the query. So we can actually look at the prepared TF record dataset printout here. For example, for features, we have query, that is the tokens, the text from the original dataset after pre-processing. The purpose of this tutorial, we only added this one single white feature here, but this is actually a float list, which means that you can actually add arbitrary number of features. For example, in the real production, we actually also use some other member behavior features here to add more personalization into the model. And so that's basically our features that we use for this model. And then we also have another feature in TF record, that is actually our label. So after we've successfully prepared our train test dev dataset that's in the format of acceptable by dtext, we can now generate our vocabulary, and that is actually the only thing left before the actual training happens. And here we just take a simple method to extract all of the tokens from our training text data. So after the vocabulary list is generated, we write it to the to a vocabulary file. And actually, if you look at it, right now we actually prepared our dev, test, and train TF records as well as our vocabulary file. So now that we have our dataset prepared, we can proceed with model training using the dtext framework. And first, we're going to define all of the hyperparameters that's available for dtext. And for more details, you can actually refer to the link that's pasted here that has all of the parameters that's acceptable by dtext. So let's first take a brief look at what kind of network or model that we're defining. So first of all, we're using the convolutional neural network, CNN, for encoding the text data. And a lot of the parameters are very self-explanatory. So we have our learning rate, the max sequence length. The max length simply means that this is the maximum sequence length allowed for the text data. And for anything that's longer than 16 tokens, so we're going to truncate to 16 tokens. And some CNN-related parameters for number of filters and number of units. I just mean the size of the embeddings. And we also will train 300 steps for training. And then for optimizer, dtext has more options, but we're going to use Atom for the purpose of this training. And we have two set of parameters defining the metrics. First one is the P metric, that is the primary metric, which is used for defining, like exporting the best models. And then for all metric, we're gonna print out all of the metrics that's listed here. So for classification, we can use accuracy and confusion matrix. And we also have some other parameters defining the logging frequencies. And also the train and test batch size can be defined. We're going to use 64 here. And we also have some other auxiliary parameters such as use deep for the ease of use for the users. So for example, you can just switch to from true to false to just generate a white only model, and that can as well be a baseline for this query intent classification. And we will need to specify our vocabulary file, and so inside the dtext model is gonna perform a vocabulary lookup and transform all of the tokens from the text data into IDs. And some other auxiliary parameters such as whether or not we want to do resume training. So if this is false, the framework will actually first delete the output folder if it exists. And for feature names, this one is actually what we just defined in preparing the data set. Basically, we have our label, our text data, which is called doc query, and then we also have our white features, that is the length of the query that we just defined. And the number of classes is 6, so this also needs to be provided. And followed by that is our train, dev, and test file location, as well as our output directory. So actually, after defining all of these parameters, we're actually ready to train the DTEX model. So let's just run it and try to inspect the training log. So since we're using a very small data set, this actually runs pretty fast. And let's wait for it to finish. Okay, so now our training has finished, and we ran it for around 300 steps. So this is actually the end of the training. We ran it for 300 steps, which is almost is about 2 epochs. So we actually iterated the data set 2 times, and you can see at each time the model evaluates it, outputs the loss, the confusion matrix, as well as the accuracy. And after the training, we will run evaluation for another time for the test data set. So in order to give the final model performance comparison. So that is actually how easy it is to train a DTEX multi-class classification model for query intent classification. And I want to also show the output to you. So this is our output folder, and if you look at it, it actually includes several different kinds of folders and files, so we can actually go through them very quickly. First, we have all of the hyperparameters saved here. This is very useful for inspecting the model after the training job. And then we also have all of our model checkpoints available here. This can be used for continued training. And we also have a network structure logging file. This file actually outputs the model architecture. You can look at basically the parameter size for each layer. We also print out the total number of trainable parameters. Yeah, so there's the network structure file. And you notice there's also another folder called export. So this actually exports the best the best model in saved model format, and after model training, you can just directly use this for model inferencing online, and we're gonna see how that's put into action in the following steps. So let's close these two first. Okay, so let's just check our model predictions and see if it really works. So first we will get the best saved model path, and it is located at this path. And then we will use a very handy tool called saved model CLI from TensorFlow to show the model's signature definitions, and you can inspect the shapes of each of the features as well as outputs. And for this multi-class classification, we are actually interested in this output, which is the multi-class probabilities. So this is actually a softmax over the 6 different classes. This is essentially the probabilities of this query being in one of the 6 classes. And then what we usually do is we can get the index or the class labels for the one with the maximum probability and just associate with the query for that class. So let's then take a look at how we can do online inferencing with our trained model. It is actually very straightforward in Python, so we can just load the saved model using the saved model path, and then we actually define a method here that takes a query and just run through the saved model to feed all of the features into the placeholders, and then we're gonna get the class probabilities, and the predicted class is actually the one with the highest probability. And the method also prints out the most possible intent class. So let's run that. And finally, we have some queries that we are very curious to get the output intent. So first one is, how's the weather in Mountain View? This is mostly associated with the get weather intent. And then similarly, we have some queries for other intents. So if you're curious, you can also try to enter your own queries to see if the model can distinguish between the 6 different intents. So if we run this, we can actually see all of the predicted intents actually match with our original intent with the query. So that means our model actually gives a pretty good prediction accuracy. Great, so that concludes our hands-on tutorial session for query intent classification. And if you're interested, please check out our dtext repo for more examples, as well as more details on how it can be used for other tasks. Thank you for attending this session.